For decades, the world believed France would always remain ahead in advanced jet and missile technology. Yet, quietly and steadily, Israel not only caught up, but moved ahead in key areas that now shape modern air warfare and missile defense. This shift did not happen overnight. It was built through necessity, innovation, battlefield data, and strategic partnerships that transformed Israel into one of the most advanced military technology powers on Earth. In the early days, France played a central role in Israel's aviation journey. During the 1950s and 1960s, French fighter jets formed the backbone of Israel's air force. Aircraft like the Mirage series helped Israel secure air superiority during major regional conflicts. At that time, France was a leader in jet design, aerospace engineering, and missile systems. Israel depended heavily on this relationship for survival. But geopolitical alliances change, and when France imposed an arms embargo after the 1967 war, Israel was forced into a new reality. That moment became a turning point. Instead of collapsing under pressure, Israel redirected its strategy towards self-reliance. Engineers were tasked with reverse engineering aircraft systems. Research and development budgets exploded. Domestic aerospace programs accelerated at an emergency pace. What began as a survival response slowly evolved into an industrial revolution. Israel was no longer just operating aircraft. It was redesigning, improving, and eventually outperforming many of the systems it once imported. Meanwhile, France continued advancing its own aerospace industry with projects like the Mirage 2000 and later the Rafale. These were powerful jets with advanced avionics and weapons. Yet France's development cycle followed traditional military timelines. Israel, driven by constant threat environments, could not wait decades for generational upgrades. It evolved in real time, adapting systems after every engagement, exercise, and operational mission. One of the first signs that Israel was overtaking traditional powers came through avionics. Israeli radar, electronic warfare, and sensor fusion systems started outperforming older European designs. While jet engines and airframes remained important, the true battlefield advantage shifted to data. Israel mastered this domain earlier than many competitors. Its aircraft could see farther, react faster, and share information instantly across networks. Missile technology became another decisive frontier. France maintained solid missile programs through European collaboration. Israel, however, focused on layered defense under constant pressure. Short-range rockets, medium-range missiles, and long-range ballistic threats forced Israel to innovate beyond existing models. Systems like Arrow, David's Sling, and Iron Dome were not just defensive tools. They became laboratories of real-world data collection. Every interception improved algorithms, tracking precision, and guidance logic. Unlike France, which tested many of its systems under controlled conditions, Israel tested its systems under live operational stress. This produced a feedback loop that no simulation could match. Each launch detection refined radar software. Each interception improved mid-course guidance. Each upgrade cycle became shorter and more aggressive. Over time, this created a massive knowledge advantage. Jet technology followed the same pattern. While France developed multi-role fighters for broad export markets, Israel customized its aircraft deeply. Whether it was the F-15, F-16, or later the F-35, Israeli engineers rewrote software, integrated indigenous weapons, and reshaped mission systems. The Israeli Air Force transformed foreign jets into unique platforms tailored for regional dominance. This level of modification went far beyond what France allowed on its own export aircraft. The F-35 era marked the clearest shift. France invested heavily in the Rafale. It became one of Europe's most advanced fighters. Still, Israel's version of the F-35, the Adia, achieved a deeper level of systems integration and electronic warfare dominance. Israel gained the rare ability to modify core software layers, something most other nations could not access. This allowed Israel to stay ahead of evolving threats faster than traditional European platforms. France focuses strongly on balanced export design. Israel focuses on battlefield survival. This difference in philosophy shaped everything. French jets are optimized for flexibility across NATO missions. Israeli jets are optimized for contested airspace, filled with dense radar, missile batteries, and electronic jamming. These priorities pushed Israeli innovation much faster in sensor bypassing, stealth optimization, and network warfare. Missiles tell another story of divergence. French programs like Exocet and Mica remain highly capable. However, Israel's work in interception, guidance, and multi-layer tracking placed it into a separate category. Israel began blending radar, command systems, interceptors, and satellites into one unified detection-to-destruction chain. Few nations operate fully integrated missile ecosystems at this scale. The global defense community began to notice. Countries from Asia, Europe, and even NATO members started integrating Israeli avionics and missile systems onto their own platforms. French aircraft in some export markets now carry Israeli targeting pods, radars, and defensive systems. This reversal reflects a deep technological shift. The former supplier became the quality benchmark. Strategic doctrine also evolved differently. France emphasizes expeditionary power projection and coalition warfare. Israel emphasizes immediate homeland defense, rapid air dominance, and threat preemption. These doctrinal paths gave Israel a testing environment unmatched by most Western nations. Real-world deployments produced rapid adaptation cycles that peacetime air forces rarely experience. Economic scale never favored Israel. France has a far larger industrial base. Yet Israel compensated with speed, software dominance, and specialization. Where France invests in broad platforms, Israel invests in narrow superiority. This creates sharper technological edges, even when overall budgets differ greatly. Another crucial factor was intelligence integration. Israeli jets and missile batteries do not operate as isolated tools. They operate as extensions of national intelligence networks. Signals intelligence, cyber surveillance, and space-based reconnaissance feed directly into air and missile operations. This deep fusion multiplies the effectiveness of every platform Israel fields. Humanitarian impact must also be acknowledged. Defensive missile systems designed in Israel have prevented mass casualties during repeated conflict cycles. Early warning systems, radar coverage, and layered interception reduce civilian exposure. While no defense network ensures total protection, the survival rates shifted enormously after Israel's missile shield matured. France has also invested in civilian protection through NATO cooperative defense. However, Israel's daily exposure forced its systems to mature under constant pressure. This contrast explains much of the technological gap that formed over time. Another area where Israel surged ahead is electronic warfare. Israeli jamming systems, decoys, and cyber-integrated battlefield disruption tools are now considered some of the strongest in the world. Aircraft today do not just fire weapons. They manipulate the electromagnetic spectrum. Israel mastered this domain earlier than most European powers. Autonomous systems also accelerated Israel's edge. Drone-launched missiles, AI-driven target recognition, and automated threat prioritization now feed directly into both jet and missile networks. France is building similar capabilities, but Israel's deployment speed remains faster. Export influence sealed Israel's leadership. Israeli missile defense systems are now deployed in Asia, Europe, and the Middle East. Israeli avionics sit inside aircraft flown by multiple allied nations. Even France cooperates quietly in certain projects where Israeli subsystems enhance performance. This transformation did not mean France became weak. France remains a top-tier aerospace power. Yet Israel surpassed France in specific high-pressure sectors: missile interception, layered radar fusion, adaptive electronic warfare, and software-driven air dominance. The wider global trend mirrors Israel's rise. Modern warfare now revolves around detection speed, network fusion, and rapid interception cycles. Kinetic power alone matters less than data dominance. Israel adapted to this shift earlier because survival demanded it. From a strategic perspective, Israel's ascent reshaped regional balances. Airspace became harder to penetrate. Missile trajectories became easier to predict. Adversaries were forced to invest in more complex delivery systems, which raised costs and reduced reliability. From a humanitarian lens, increased interception capability reduced civilian vulnerability. While regional conflicts remain politically complex, technological protection layers saved lives across multiple escalation cycles. In the long view, Israel did not replace France as a traditional aerospace empire. Instead, it became something else entirely. It became the world's fastest battlefield laboratory. Every conflict cycle compressed decades of learning into just a few years. France builds excellence in measured phases. Israel builds it under continuous urgency. As jet and missile warfare continues evolving towards space-based sensors, AI interception, and cyber-integrated strikes, the advantage will belong to those who adapt fastest. Israel's model proves that innovation speed can overcome even large industrial disadvantages. This is why today, across many classified comparisons, Israel is no longer the student standing behind France. In critical jet and missile technologies, it now quietly shapes how the future of air warfare is written.